Okay, you guys, let's do some log practice. So here is my suggestion to you guys on this, doing this homework. Please try not to use your calculator as much as you can. The goal should be to get comfortable with logs, have a sense of what they're saying and what they mean. So, for example, we know that 4 to the second power is 16, okay? A lot of us have a sense for that, right? 3 to the second is 9, or 2 to the third is 8. You know, when we see an exponent situation, a lot of times we can take a second to think about it and we know what it means. But we may not as obviously, especially now that it's brand new, be comfortable knowing that log base 4 of 16 is 2. Or that log base 3 of 9 is 2. Or that log base 2 of 8 is 3. Okay? But these are basically the same expressions as those. So if you just go with a change-based formula to your calculator, you're not going to get a sense of what logs mean. And we got to practice it to get that sense. So they're new now and it's a little hard, but got to do it. I think you got to do it. So please do it. All right. So remember that the way we read a log is, actually, let's do number 1 and I'll go over it. So number 1 says, which equation is equivalent to log base 3 of x equals 8? I want you guys to practice reading this properly. This is not log 3 to the x, okay? This is log base 3 of x is 8. Okay? That's how we read it. And what it says, what this mathematical expression says in English is 3 to the 8th power is x. Okay? That's what it means in exponential terms, I should say. Okay? So 3 to the 8th is x. So we could write that. Oh, wait, what? I wanted to write a 3, but I wrote an 8 because I was thinking about 8. 3 to the 8th is x. Okay. That's what it says. And that's what this question is asking us. And so here it is, okay? But let me give you a couple little hints on how to quickly eliminate some wrong choices, all right? The base of the log is 3. So it must be equivalent to an expression whose exponential base is also 3, whose exponent base is 3, okay? So it cannot be these two whose exponent bases are x, okay? So exponent base must match log base. And then the next thing that I just know is that the order in which these appear cannot be exactly the same. So it can't be 3x8, 3x8. So these are like little ways, if you just want to look back while you're still a little bit iffy with log because they're so new, you want to look back and do a quick check and see if you feel good about the choice you made. Those are my little hints to give yourself that confidence that you are correct. Okay, let's keep going. Which equation is equivalent to 7 to the x equals 450? Okay, so as a log, this would be a log with a base matching the exponent's base. So the base must be 7. And then it's going to be the power. This right here, the exponent, the power, is what our log gives us. So that is going to be right there. And then the 450 goes right here. Okay, so if you recall the triangle puzzles too, This would be a 7 to the x equals 450 in those triangle puzzles. So then in log terms, it'll be log base 7 of 450 equals x. So exponent terms go around this way, log terms go around that way. But either way, we do begin with the base, with that first spot in that triangle from the amplify lesson. Okay, there we are. Should we do our little checks from up here to see if we feel good about this? The base of the exponent matches the base of my log, check. And then the numbers, they really shouldn't appear in the exact order. 7x 450 shouldn't be what we have. We have 7 450x. Okay, cool. Again, this isn't something I would want you to be relying on all the time, but if in the beginning it makes you feel good about your choice, then that's good. B. Okay. Oh, we're solving. How fun. Okay. To solve this equation, now you can go straight into, this is a log base 32 of 65536 equals x. I do think it's worth understanding algebraically that you can solve this by doing the inverse operation. So the inverse operation of a 32 to the power of x is a log base 32. And I must do it to both sides of my equation. All right? Because anything I do to one side, always got to do to both. So now that I've done that, the log base 32 cancels out the exponential base of 32, leaving me with just x on this side. And then on this side, I have log base 32 of 65,536. Okay? And if you see, it's the same thing. All right? Okay. And now we could try to go into this guess and check game, but why do that when we've got our calculator and we can do the change of base formula by checking out what log of 65536 is. So x will also equal log of 65536 divided by log of 32. Okay, and you can get the same thing using ln instead of log. ln is a natural log with a base of e. Okay, and just because students tend to be a little bit afraid of ln, I'm going to use that one because I want us to break that fear. So ln, but if you want to use log, go for it, and you'll see how you'll get the same answer as me. ln of 65536, close the parenthesis, divided by ln of 32. This one you don't really have to close. It's 3.2. Ooh, good thing we didn't guess and check. That would have taken forever. X equals 3.2. Final answer. This was the change of base formula. Okay, let's go. Match each logarithmic equation with its equivalent exponential equation. And this is going to be a piece of cake because look at these bases. They're all different, all right? So the one with a log base 3 must match this guy with the exponential base of 3. The one with the log base x must match the exponential base of x. And the one with the log base 9 must match the exponential base of 9, okay? So I do want to double check, though, that the rest of the things are in the correct order. 3 to the power of x must equal 9. We can also make that triangle puzzle. This would be it's a log, so it would be 3, 9, x, which means in exponential form it would be 3 to the x equals 9. X, 9, 3, which is x to the third. Wait, I did that one wrong. That didn't make sense. Sorry. The triangle is new for me, you guys. This is a log, so we would go x3, 9 this way. And it would mean that x to the 9th is 3. And this one, 9x3, 9x3 this way, 9 to the 3rd is x. Perfect. Okay, all good. Let's keep it going. Oh, we're solving. We're solving these two. So again, just like the other problem that we solved, you can either log base 49 both sides. I do like that. I like us understanding what we are truly doing algebraically. And then the log base 49 cancels the exponential base of 49, leaving me with x equals log base 49 of 16, 4. Oh, I know. 16, 4, 6, 164,807. Okay, or, take your pick of all the different ways. You could have turned this into, the base of the exponent, that is the base of the log, and it's this number, that number. You could have turned it into the triangle puzzle with the exponent, where 49 to the x equals 64807. And then you wrote it in log terms this way. Whatever you want to do, either way, we land here, where now we're going to do the change of base formula by doing log or ln of that number divided by log or ln of that number. So x will equal, I'm going to do ln again, because I want us to break the fear with ln, you guys. ln is far more commonly used in math than logs. I just don't want you to develop a fear of them. So then we come here and we do ln of 807. Don't forget to close this parenthesis, and then divided by ln of 49. 3.087. X is approximately 3.087. Okay, let's prove it. Let's prove it that log would get us the same thing. Log of 164,807, close that parenthesis, divided by log of 49, 3.0867, same thing, you see? So just don't mix them, don't do one ln and one log. As long as you're consistent, they're going to come out right. Okay, now here. So again, this is x 64, 2, which is really just saying x to the second is 64. Okay. This is not at all a exponential equation. This is quadratic, okay? I can solve this guy by simply square rooting both sides, okay? And then I would get that x equals, okay, technically I would get x equals plus or minus 8. However, with the log base, we don't do negatives. So we're just going to go with x equals 8. Okay, let's keep it going. Ooh, fun. Here we go. We're going to fill in the blanks with any numbers to create two equivalent equations. That's fine. This one gives me no boundaries at all. I can plug in whatever I want. Whereas this one has that 1/2 right there. which tells me I should start here. Okay, so I want whatever this is to the power of that to equal that. That's what a log says, right? Like, let's just pretend that this is A and this is B. This would be A, B, 1/2, which is saying A to the power of 1/2 equals B. And what that means is, that means this needs to be 1/2 right here. It says with any numbers, yeah. Okay, so that basically just means a 1/2 power means square root. So I need whatever I pick for A to be B squared, or whatever I pick for B to be the square root of A. So how about 9 and 3? Wait, no, did I do that the wrong way? I did. A would be 9, so the square root of 9 would be 3. So switch them. There we go. As long as you put a number here and the square root of that number there, you're good. So equivalent expression-wise, 9 to the 1/2 is 3. Okay, let's keep it going. Spiral Review wants us to remember some stuff, okay? They want us to remember that anything to the 0 power is 1. They want us to remember that a 1/3 exponent is a cube root. So the cube root of 27 is 3. Then they want us to solve these equations for x. So 4 to what power is 16? X is 2. 4 squared is 16. And 4 to what power is 1/64? Well, 4 to the 3rd power is 64. But what exponent will make it flip, will make it do the reciprocal? A negative one, okay? So in our situation, we have 4 to the negative 3rd equals 1/64. So x equals -3 here. Okay. Here we go. 6.8. Fill in the value of each expression. Let's do it. We're going to still try not to use our calculators, you guys. I know you can go change of base formula with this. Don't do it. Don't do it. Okay? I want you to understand this is saying 2 here, 32 here, unknown value up here. 2 to what power equals 32? Okay? And that is 5. Now, I guess at this stage, if you didn't know that, you could go fill it in. But there are just some, like, common ones. You know, they love 2 to the 3rd is 8. They love 2 to the 5th is 32. These things just tend to come up a lot. So just get your eyes used to some of these. All right, 2 to the 4th is 16. And you'll see it. Okay, moving on. Over here, 4 to what power is 1/16? Or in log terms, 4 1/16x. So in this case, 4 to the 2nd power is 16. But in order for it to flip and become the reciprocal, it needs to be negative. The exponent needs to be negative. A negative exponent makes us flip and do the reciprocal, which is why this spiral review question was asked earlier. So please remember that, okay? In exponent world, a negative exponent gives us a reciprocal. Okay, log base what of 8 is 3? So what that's saying is what 8, 3. X to what? X to the 3rd power is 8. So what's x? That's 2. 2 to the 3rd power is 8. All right. And now over here, 5 to what? I'm sorry, log base 5, that's the x, and then right here, this goes on the top. So this is saying 5 to the negative third power is what? Well, 5 to the third power, that's another one they love. 5 to the third is 125, so 5 to the negative third is 1 over 125. Select all the expressions that are equivalent to 4. Okay. ln of 4. That's not 4. That's ln of 4. Okay. No. I'll come back and explain that maybe more in a bit, but that's just that's not it. Let's keep going. Log base 4 of 16. Let's see what this is talking about. So the 4 here, a 16 here, and then this is what we don't know. So what this is saying is 4 to what power is 16? And it's 2. 4 to the second power is 16. So this is not equivalent to 4 either. All right, I'm going to put an X right there. This one says 2, 16, and then what would be here in the puzzle? 2 to what power is 16? That's the fourth power. 2 to the fourth is 16. So this one does equal 4. And now here, ln is the terminator, programmed to go find an exponential base of e and kill it. All right, so the ln does its job. The terminator is good at doing its job, kills the e. Those two wipe each other out, and now we just have this equaling 4. This one. Okay. Which now let's go back to here. That's why this one wasn't it. There was no e. The ln doesn't go away here and just become 4 because there was no e to take each other out. All right. Okay. And then, so, no. And so over here now, this is 16 and a 2. So what number goes here? 16 to what power is 2? It would be a root, which means it would be a fractional exponent at 1/4. So this equals 1/4, not 4. This one's also out. Okay. Write a logarithmic expression equal to 3 using ln. Okay, so I want the ln of something to equal 3. So for this ln to go away and it to just have a 3 there, I need an e. But that e needs to be an exponential base, which means it needs to have an exponent. And the exponent is going to be what survives, so it needs to be 3. Look at that. All right, just like this one was 4, this one's going to be 3. Okay, they want me to write a logarithmic expression using fractions between 0 to 1 to equal 3. So it needs to equal 3. This needs to be log right here. They want a log to equal 3. So a log base something of something to be 3. So 3 is our exponent. I want something to the third to equal that. And I want there to be fractions there somewhere. So why don't we pick like a nice fraction that's not too scary? Let's go with a 1/2. So we can make the base of our log 1/2. And so then 1/2 to the third would be 1/8. That would go there. Okay, log base 1/2 of 1/8 equals 3. Cool. And I know, using the number 3 to fill in different parts of the expression. What? Okay, so I assume this stands because it says for problem 6 to 8 and this is 8. So I assume we still want a log that equals 3, but I think they want more 3s. So like maybe they want one with a base of 3 or one who we're taking the log of 3. So let's see what that would entail. Okay, in this situation, we have 3 to unknown value equals 3, like this, which means 3 to the third. That means this would be 27. 3 to the third is 27. And then in this one, we want the base of the log. So that's our unknown, is the first spot. And then a 3 here to be 3. So what to the third power is 3? That's, do we write cube root of 3? Do we write 3 to the 1/3? I'm trying to think of, you could do either one, you guys. So basically, you need a 3 here with an exponent, something that this exponent of 3 would cancel. I'm trying to figure out the best way to explain this. The exponent of 3 cancels out either a cube root, right? Cube root to the third, cancel, and we'll get just 3. Or it will cancel out a 1/3 exponent, because 3 to the 1/3 is the same as a cube root. But anyway, to the third, 1/3 times 3 cancels out, leaves us with 3. So whichever of these two you want to write there works. I'm going to go with, you know what? I'm going to go with 3 to the 1/3. Just because this is logs and exponents. Let's stick with the theme. Okay, let's see what this number 9 is about. Using the numbers 0 to 9 only once, fill in the blanks to write a true statement. I want the log base something of a 2-digit number to equal log base something of a 1-digit number. So let's see what we're talking about here. So I want, let's say this is A. Let's say our 2-digit number here is B. B needs to be a 2-digit number. So this would mean that an A here, a 2-digit number B here, needs to equal something. And that something needs to equal this as well. So then, like, if this is C and this is D, then we need C, D to be the same something. So I need a 1-digit number to the X to become a 2-digit number. And then I need a different 1-digit number that to the same exponent gives me a 1-digit number. So this seems fine. This is not so bad. The only thing is we can't repeat numbers. So I'm starting to see this play out right now. So I'm thinking I like a 3 for the exponent. Okay, the reason I like 3 for the exponent, we could go with 2. We can go with 2. We could go with whatever you want. All right, I think it'll all work as long as we don't go too big with the exponent. So in order to take a single-digit number to an exponent and have it like stay a 1-digit number, we don't want this exponent too big, okay? So I think the exponent should be either 2 or 3. And I think we can make it work with either one. 3, yeah, we can, right? So if X is 3, then, oh wait, we don't have to use that number. X isn't a digit that we use here. So that doesn't actually even matter as much as I thought it did. I just thought, okay. So now I can do A to be 3. And 3 to the third would be 27. And then over here, if C is, let's say, oh, but now we can't use 2. That's what I knew would happen. Okay, forget it. Let's change A to 4. If A is 4, no, then that's 64, and we can't use 4 again. And then if it's 5, it becomes a 3-digit number. See, I was right. We cannot use 3, you guys, as the exponent. It didn't work. So we got to use 2. The exponent's going to have to be 2. Okay, so now I need A to be something that when squared is a 2-digit number. So A has to be at least 4. If A is 4, I get 16 here. It's a 2-digit number. That works. And then over here, I need C to be a number I have not yet used. So 3. And when squared, it's a 1-digit number that I also haven't used. Boom. Okay, we did it, guys. Let's go see it. A is 4. B is 16. C is 3. And D is 9. Okay, looking at it now, that was so much simpler than I made it out to be, you guys. A 2-digit number whose square root is here. A 1-digit number whose square root is here. That's all this problem was. But sometimes it's hard to see that. So, there we go. All right. So, by that logic, no, 25 and 5, we can't do that. 36 and 6 couldn't have done that. 64 and 8 we could have done here as well. 6, 4, and 8. That was another option. Okay, moving along. Write the integer power of 3 that is closest to 100. Okay. So 3, we know 3 to the third is 27. So 3 to the fourth is 27 times another 3. That's 81. Or 9 times 9. That also works, 81. And I think that's where it's going to end, because 81 times 3 will for sure be way over 100. So 4 is the closest we'll get to 100. Write the integer power of 5 that's closest to 1,000. Okay, well, you guys, exponents, they grow fast. So don't worry, this is not going to be as hard as it looks. 5 to the third is 125. I also know 25 times 25 is 625. So I know 5 to the fourth is 625. And then I know 600 times another 5 is like 3,000. It's a lot. So this is actually the closest we'll probably get. You also could use a calculator here, I guess. So you would go like 3 to the fourth, 81. 3 to the fifth, oh no, too big. All right. 5 to the fourth, 625. 5 to the fifth, oh no, too big. Okay, that's it. Okay, guys.